clouds in the sky, hoping for the best but expecting the worst. Are you gonna drop the bomb or not? Let us stay up, let's live forever. We don't have the power, but we never say never. Sitting in the sandpit, life is a short trip, the music of the sad man. Can you imagine when the space is one? Turn our golden faces into the sun, raising up.
Neural networks. Hello, I am a YouTuber Amel Olin. Welcome to the discussion Neural Network for Classifying Squares, Triangles and Circles, Part 1. Neural networks are the basis of deep learning. A subfield of machine learning where algorithms are inspired by the structure of the human brain. Neural networks take data, train themselves to recognize patterns in this data, and then differentiate the output for new similar data. Let's understand how this is done. Let's construct a neural network that differentiates between circles, and triangles. Neural networks are made up of layers of neurons. These neurons are the main processing units of the network. First, we have an input layer that receives input. The output layer differentiates the final output. In between are hidden layers that utilize most of the computation required by our network. This is an image of a circle. This image consists of 28 by 28 pixels, which has a size of 784 pixels. Each pixel is given input to each neuron of the first layer. Neurons from one layer are connected to neurons from the next layer through channels. Each of these channels is assigned a numeric value known as a weight. The input starts with the weights based on and the source is given as input to the neurons in the hidden layer. Each neuron is associated with a numerical value called bias, which is then added to the input source. This value is then fitted through a threshold function called activation function. The result of the activation function determines whether a particular neuron is to be activated or not. The activated neuron sends the data to the neurons of the next layer through a channel. In this way, this data is propagated through the network. This is called forward propagation. In the output layer, the neuron with the highest value fires and knows the output. These values are probabilities. For example, here, our neuron associated with the circle has the highest probability. So, that is the output predicted by the neural network. This process continues until our weights are incorporated so that the network can predict the shape correctly in most cases. This brings our training process to an end. You might be wondering, how long does this training process take? Honestly, neural networks may take hours or even months to train. However, the time is a good difference when compared to its scope. Let's look at some of the major applications of neural